All right, morning, grade 7. It is Tuesday, and by my calculations, after today, I believe you only have 13 days left of school, which is actually kind of unreal if you think about it, but it's definitely starting to feel like summer with the nice warm weather we're planning to have this week. Okay, so today we're starting lesson 11.3 on combinations. Now, I'm going to warn you ahead of time, it is kind of a tricky lesson. It's doable, but you really have to understand what you are doing. So for that reason, we're actually going to take Tuesday, Wednesday, and Thursday of this week to go through this lesson step by step. So if you're confused, please ask me a question. I'll be able to help you, and it won't take very long for you to figure it out. So in yesterday's lesson on Monday, we talked a lot. I used the word combination, but what I really should have used more was the word permutation. So yesterday's lesson was about permutations, which is a special type of combination. But today we're just going to learn about a combination in general. So let's take a look at a question like this. Let's say I have 2 extra tickets to a Blue Jays game and that we're allowed to go to the Blue Jays game. I have 5 friends that are interested in coming along. Their names are Anne, Bob, Carl, Dave, and Eli. Notice how I just made it basically A, B, C, D, E. I am asking the question, how many groups can I take? Well, the important thing is that I have 5 friends, but I only have 2 tickets. So only 2 of my 5 friends can come. So what I've done is I've created a sample space where I've put together, Anne takes Bob, Anne and Carl go, Anne and Dave go, Anne and Eli go. Then Bob and Anne go, Bob and Carl, Bob and Dave, and Bob and Eli. And I keep going. And I've created this sample space, and I've noticed that I actually have 4, 8, 12, 16, 20. I have 20 different groupings that I can take with me to this Blue Jays game. So that's creating a sample space. But before we go further to this question, I want to talk a little bit more about permutations and combinations. So permutations was yesterday's lesson, where order matters. For example, if we were to choose a president from our class and a vice president, perhaps we would choose the president first. So let's say we do a vote and maybe Mackenzie Kickert becomes the president of our class. Okay, so she is one of 26 students in our class. She becomes the president. Now we want to vote for the vice president. Well, because Mackenzie's already the president, she can't be the vice president. So now we only have 25 choices for the vice president, and maybe Griffin becomes our vice president. So that's a scenario where order matters. Same if we're talking about first and second place in a race. Let's say we're running a race and Kieran ends up in first place. He can't end up in second place. Maybe Judah's in second place. So if we had Kieran and then Judah, that would be very different than having Judah and then Kieran, right? They would end up with different ribbons, say on field day. Or you can think about the example I gave yesterday with popsicles. You want to have, typically speaking, the first choice of a popsicle. So the order matters because there's fewer choices the further on down you go. So that's a permutation. The order matters. So Kieran and then Judah, first then second, is different than Judah getting first and then Kieran. They have the same letters, but it's a different grouping, okay? That's a permutation. The order matters. But now today we're talking about combinations where order does not matter. So for example, let's say, I think in high school here at Heritage, for Stuco, you pick 2 class representatives. The order doesn't matter. There's just 2 people that are picked as representatives. So let's say maybe we have Eric is picked as a class representative, and then Devin is also picked as a class representative. That's not any different than Devin and Eric being class representatives. We still end up with the same combination. So actually, Devin and Eric is exactly the same as Evan and Derek, or Eric and Derek. I switched my names. Wow, Eric, Derek, Devin, Evan. You know what I'm saying? Eric, Devin. Or I could say Evan, Derek. You get the idea. So the point is that when I'm picking class representatives, the order doesn't matter. Or if I'm talking about toppings on a pizza, if I were to put ham and mushroom and pineapple on my pizza, that's no different than if I put pineapple and then mushroom and then ham. It's not a different grouping because the order doesn't matter. I still end up with the same kind of pizza. Then I have here this example of a combination. Who gets to go to a concert there's only 2 tickets. So let's go back to my original question here. Okay, I have 2 tickets to the Blue Jays game, and there's 5 people that are interested in coming along with me. But remember, in this type of question, the order doesn't matter. Whether or not I take Ann and Bob with me, or Bob and Ann, that's actually not a different grouping. It's repeating, because when I'm sitting at the Blue Jays game, I still have Bob and Ann with me, or I have Ann and Bob. So this actually ends up being a double. Bob and Ann is the same as Ann and Bob. So what we can do actually with our sample space is we can work through it and we can cross out any things that are double. So if I look across Ann and Bob, Ann and Carl, Ann and Dave, and Ann and Eli, that's all fine. Then I've already crossed out Bob and Ann, because that's the same as Ann and Bob. Now I have Bob and Carl. I can double check. Have I had that combination? No. So that one's fine, that one's fine, that one's fine. But now look, Carl and Ann, well, that's the same as me up here taking Ann and Carl. So I'm going to cross that out. Same with Carl and Bob. That's the same as me taking Bob and Carl. So I'm going to cross that out. Then I can keep going. Dave and Ann, well, I already took Ann and Dave, Dave and Bob. I already took Bob and Dave. And Dave and Carl, I already took Carl and Dave. So that also cancels out. Then I can keep going to Eli. Eli already went with Ann. Eli already went with Bob. Eli already went with Carl. And Eli already went with Dave. So really, you'll notice it's just this handy bottom triangle. Those are all the doubles, okay? So before, I actually had 20 permutations where order mattered. But that's not really what I'm looking for. I'm just looking for the different combinations. And if I count them up, I actually end up with only 10 combinations. There's 10 different groups of people that I could take with me to this Blue Jays game. So what I want you to start to notice is that combinations, they come from permutations, but we actually have to narrow it down, and we always are going to end up with a smaller number because the order doesn't matter. So taking Ann and Eli is the same as taking Eli and Ann. So I'm not going to count it twice. Those are not 2 different combinations. So this is actually method A, where you create a sample space. Today you're going to do a worksheet. It only has 3 questions on it, and it's going to ask you to use each method. So here's an example of method A, where you create a sample space. You write out all the different permutations it could be, and then you cross out all the ones that are doubles or duplicate to end up with our final answer. Okay, so that's method A for combinations. Now let's talk about method B. Method B is very similar to method A. We're going to create an organized list. So when I do that, it's similar to before. I'm going to go, well, Ann and Bob can go, or I can take Ann and Carl, or I can take Ann and Dave, or I can take Ann and Eli. So when I'm creating this organized list, I note to myself, look, I've taken Ann 4 times with 4 different people. So in a way, I've sort of used Ann already. She said those are all the different ways she could come to the game. So I'm going to cross her out. Then I'm going to take Bob. Now notice, I crossed out Ann over here because Bob already went with Ann right up here, AB. So I'm not going to say Bob and Ann. I'm going to do Bob and Carl, Bob and Dave, and Bob and Eli. Now Bob's gone 4 different ways. I'm going to cross him out. Then I'm going to do Carl and Dave, and Carl and Eli. Carl's used up. And then finally, I'm going to do Dave and Eli. And we used up Dave, and I'm going to double check. Actually, Eli, if you look, Eli's already been in 4 of these different combinations. So I can count up my final answer, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I once again have 10 different combinations. There's 10 different groups of people that I can take with me to the Blue Jays game. Now, just like yesterday, or actually I think it was last week Thursday when we talked about the fundamental counting principle, we don't always want to be drawing out these sample spaces. Like, what if I have 5 tickets to a concert and I have 20 friends that want to go with me? You can imagine how long it would take me to write out a sample space or an organized list. So, thankfully, there's a mathematical expression, and this is going to be method C, that we can use to figure out how many different combinations there can be. Now, in order to do that, we need to think back to, what if this was just a permutation? And remember, a permutation is sort of like that popsicle question, right? Where we pick something or someone, and then that person or that something is gone, or it's been sort of used up. So what I can do is, sorry, went too far. I can think about the fact that I only have 2 tickets, right? Only 2 people can come with me to the Blue Jays game. So let me just think about it as if it were a permutation. I think to myself, okay, I have 2 tickets. So let me think about ticket number 1. How many people can I choose to come with me? Well, I have 5 choices. So let's say I picked Anne. Doesn't really matter who I pick. But now for my second ticket here, ticket number 2, I've already used up either Anne or Bob or Carl, Dave or Eli, and I actually only have 4 choices, which remember would give me 20 different permutations. But we know from over here with our messy sample space that if I just were to do 5 times 4 and get 20, that I would actually have a lot of doubles, right? I would have an Anne and Bob and a Bob and Anne. So I want to get rid of that. So, and this is where it gets a little bit tricky. But basically what I do is I'm going to divide by the number of ways I could create this grouping. So my first one is I just do my usual, how many spots do I have? How many choices? I have 5 times 4. But I'm actually going to divide by the amount of ways I can group those 2 people. And that is actually using a factorial. Look, I can divide by 2 times 1, which is 2 factorial. Because there really are only 2 different ways to arrange 2 people in a group, right? Let's say you have 2 people standing against the whiteboard. Maybe we have Laura and Jamie. You could have Laura on the left and Jamie on the right. Or you could switch it around, have Jamie on the left and Laura on the right. There are only 2 different ways to arrange those 2 people. So this mathematical expression, I'm going to divide by 2 factorial, which is really just 2, and I'm going to end up with 10. Okay? Another way to think about that, grade 7, is to think you start over here, let me point, with your permutation, right? I have 2 tickets, so I do 5 times 4. And then I actually divide, ironically, my factorial is always going to be based on how many of those spots I had before. So in this case, 2 spots, so 2 factorial. So let's try that one more time. Okay, so there is this pizza place just down the road from my new house with my sister called Maestro's Pizza. And they have amazing pizza. And they often deliver coupons to our house. So let's say that Maestro's Pizza has 10 different pizza toppings. And they have a deal where you can get a medium pizza on sale, but you're only allowed to choose 4 toppings. So let's figure out how many different, not really how many different toppings, but how many different combinations can I make? So let me start with, what if it was just a permutation, right? You can think of it. I have, and this is always just a good idea when you're working with permutations and combinations, is to draw out your different blanks, right, to fill it in. So let's say I'm picking my first topping. I have 10 different choices for my first topping. Maybe I pick mushrooms. Then my next topping, I only have 9 choices left because I already used mushrooms and I can't repeat. Maybe I'm going to pick bacon. Then my next topping, I have 8 choices left. Maybe I'll pick ham. And then my last topping, I only have 7 choices left. And maybe I pick pepperoni. So it's essentially a meat lover's pizza. Now, if I were to calculate it all out, I would end up with quite a large number, right? 10 times 9 times 8 times 7. That would give me all the different permutations if order mattered. But remember, if the man making my pizza at Maestro's Pizza, let's say he puts on the mushroom and then the bacon and then the ham and then the pepperoni, is that any different than him putting on the pepperoni and then the ham and then the bacon and then the mushroom? It's not. It kind of looks the same, but it's not different because it's a combination. Order doesn't matter. I'm still going to end up with the same kind of pizza no matter what order he puts it on. So I'm going to take all the permutations that I found, and I'm going to divide by a factorial. Now remember, there's two ways to figure that out. I'm going to ask myself, how many different ways can I arrange these 4 toppings? Well, I can go like this. 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. So I'm actually going to divide by 24, or I can write it like this. I'm going to divide by 4 factorial. Now remember, if that's confusing for you as to why I end up with this and why I go like this, you can also just think to yourself, well, how many blanks did I have? I had 4 blanks, so I'm going to divide by 4 factorial. I'm not going to actually do the math, but you could. Okay, so just to summarize, what's the difference between a permutation? Maybe think this. Permutation starts with a P. Think about position or placement. Position or placement matters. So if I look here, let's say this is a bike lock. Let's say my bike lock or its code is 123. If you put 321 on my bike lock, it's not going to open for you because order matters. Or if you put 132. So these are all different permutations because the position matters. Whereas on combination, if I put ham, bacon, and onion on my pizza, or onion, bacon, and ham, or bacon, onion, and ham, it doesn't matter. I can write it different ways. I'm still going to end up with one combination. So permutation, position matters. Combination, you could think, couldn't care less, right? Permutation, position, combination, couldn't care less. All right, and then one more thing that I think some of you are going to have questions about is this question of when I use a factorial versus the fundamental counting principle. Factorial is really when we're going to be using things up, so to speak, right? So if you look in my birthday bin and there's 10 kids and there's 10 prizes, the first kid goes in, they would have 10 choices. The next kid would only have 9 choices, and the next kid would only have 8, and so on. So we're using it up and our choices are disappearing. Whereas the fundamental counting principle is like if I'm at a sub shop and I have different categories. Maybe you think about the counting principle, you can think about the C word, categories, which I clearly cannot spell today. Okay, so that's a sub shop where maybe you need to pick one kind of bread, one kind of meat, and one kind of sauce, right? And then maybe there's 3 bread choices, there's 5 meats, and there's 2 sauces, and you multiply those out. Okay, so the fundamental counting one, it's picking something from each category. I'm not using up choices. Okay, so hopefully that's not too confusing, but if it is, just message me. It'll take me just a minute or 2 to help you and get you back on the right track. I kept today's actual assignment very short because I think this will be actually, by the time I'm done, quite a long video. So call me if you have any questions, and I hope you have a great day and enjoy the beautiful weather.